Now look at the checksum field of TCP. If you see that header 1, 2, 3, 4, 5, fifth row first part is checksum. So we are having 16-bit checksum. So checksum here is 16-bit, right? So 16-bit checksum is used, and how it is used is, previously we had seen checksum at IP, but then that was IP header checksum. So already we have seen that IP datagram is also having a checksum field, which was header checksum, which means checksum is computed on the IP header. Now I am showing you that inside this IP there is TCP present. Now in TCP it is simply checksum, not the header checksum, which means in TCP checksum calculation it takes care of TCP header as well as TCP data also. So checksum is calculated both on TCP header and TCP data as well as on IP header too. Already IP header checksum is computed once, and again we are going to compute the checksum on IP header at TCP also. Why is that so? Which means TCP header and then TCP data and then IP header. On these three fields checksum is computed. So why do you think that checksum is computed on this IP header also? So in order to explain you, I'll just take an example and explain you. Just watch it. Let us assume that there is a house here and there is a house here. In some, these two are in different places, different cities, and there is a person here and who wants to write a letter, let us say love letter, to a girl here, right? And let us assume that he has written the entire letter, and then he has written to some Janu and all and everything, blah blah blah, and then yours lovingly he has written his entire address. He has written that my name is so and so and entire address, and he has kept this letter in an envelope. And now this envelope, on the envelope he is going to write the to address. Let us assume that the house door number is 100, so he has written door number 100 and the full address completely, and he has sent it, right? And now by mistake, when this letter is on the way, the address on the envelope got corrupted such that it has reflected a different address, which means instead of having 100, by the time the letter is going on, it reflected a different address, and the address on the envelope got changed to door number 101, and inside that there is this love letter, and therefore it is delivered to a different house, which is not this house, right? And assume that there is also one more girl there, right? And the worst case is, let us say she is married now. Now what happens? Now you are sending a letter. Already on that letter there is address, and inside that your address is also there, but now that letter is having a different address, right? So what will happen now? Now if it is found out that you are writing a letter to a different girl, then there is a problem, isn't it? Already there is some person here, there is a problem with that. Now how can you stop it from happening? Which means you don't want the letter to be delivered wrongly to the wrong person, right? So how can you stop it? So one solution is, instead of writing the address on the envelope, you write the address inside the letter, right? Which means on the letter inside the envelope. But then if you write it only inside the envelope, then the postman will not be able to see the address. Therefore write the address on the envelope as well as inside the envelope on the letter. Write the address 2 times. So that is how here also the same thing is happening, which means this envelope is nothing but IP packet, and inside that the TCP packet is nothing but the letter. Now instead of checking the checksum once, instead of using this IP header once, we are using the IP header checksum here as well as here, so that if there is anything wrong, 2 times it will be verified. Which means whenever the packet is delivered to the host, if the letter on this, the address on this is going to say that it is the same address, fine, but then again before opening the letter and then reading it, one more time it will be checked whether it is received by the same process or not. Which means at transport layer we have one more checking, at network layer we are going to have one checking whether it is given to the same host or not using the IP address, and again at network layer we have one more checking whether it is given to the same host or not. So similarly here, so for that reason what we are going to do is, at TCP, checksum is calculated on the TCP header as well as TCP data, and along with that checksum is calculated on the TCP header also, IP header also. So in the calculation of IP head, this TCP checksum, we are going to include TCP header plus TCP data plus IP header. But there is a small problem if I use the IP header here. The problem is, if I use the entire IP header, at sender we are going to get some value for the checksum, but at the receiver side, by the time this packet is received by the receiver, the checksum might change. The reason is many of the fields in the IP might change. So we are not going to include the total IP header. The reason is many of the fields are going to change. So if you compute the checksum using the IP header at the sender, and again at the receiver, if you include TCP header, TCP data, which will not change, but if you take again the IP header and recheck the checksum, then that will show a different value. Therefore we are not going to include all the fields in the IP header in the checksum calculation. So how we are going to use only important fields which are not going to change definitely. So what are the fields that doesn't change is, source IP is not going to change when the packet receives the destination, and destination IP doesn't change when the packet reaches the destination, and along with this, protocol field. The protocol field doesn't change, which is nothing but the TCP inside it, and along with that, TCP segment length. TCP segment length doesn't change. TCP segment length is nothing but total length minus header length, which is nothing but TCP segment length, and this field is zeros, right? So 8 bits of zeros are used, 8 bits of protocol field is used, and 16 bits of TCP segment is used, and 32 bits and 32 bits. So this is called as pseudo IP header, not the real IP header, pseudo IP header. So while calculating the checksum at TCP, it is calculated on TCP header, TCP data, as well as pseudo IP header, not the complete IP header. Okay, and along with this pseudo IP header, the pseudo IP header is just used in the checksum computation, but this is not actually transmitted. Other side will derive it from the IP header. So this part is actually used only in the computation and not used in transmission. So what will be transmitted is only IP header checksum. Okay, sorry, IP checksum in the header. So that is all about the checksum. So one important question is, they will ask you why IP pseudo header is included in the TCP checksum, even though already IP checksum is computing on the IP header. The reason is we want to have a double checking. One is at the network layer using the IP checksum, and other is at the transport layer using the pseudo header, right? So therefore we are using it 2 times. This will ensure that a packet is by mistake not delivered to a wrong host. So the problem is, if something happens in the IP header, and if this IP address is, let us say, IP1, and this IP address is IP2, and by mistake there is a small error in the IP header and IP1 got changed to IP2, and the IP checksum is not able to catch it, then what happens is the packet will be wrongly delivered to IP2, and inside that IP2, if there is a host with the same port number, if you wanted to send it to port number 80, here also there is a host with port number 80, then the packet will be delivered to this process. So before delivering the packet to this process with 80, we again cross check whether the destination is actually right one or not by using this pseudo header. That is how TCP checksum is going to do double checking before delivering the packet. It is all about the checksum field.